Hi everyone, in today's video we're going to be taking a look at an example of power series. So in this example we're asked to find the interval of convergence of the series k factorial over 3k factorial times x to the k. So feel free to pause your video, work through your own solution, and I'll be back with mine. So we're going to begin by examining the series, the absolute value of k factorial over 3k factorial times x to the k. By nature of these factorials, they're never going to be negative. They're always going to be positive. So we're just left with setting this sequence b sub k equal to k factorial over 3k factorial times x to the k. Absolute value of x to the k, rather. So since factorials are involved, we're going to want to use the ratio test. That's always something to keep in mind when you have factorials because as the ratio test's name suggests, we're going to be dealing with ratios, and it's easiest to cancel out factorials when we're dealing with ratios. So here we're going to be taking the ratio of the sequences, and we're going to get k plus 1 factorial over 3 times k plus 1 factorial times 3k factorial over k factorial times the absolute value of x to the k plus 1 over the absolute value of x to the k. So we're going to have a lot of terms cancel here. First, we got this term, k plus 1 factorial is just the same as k plus 1 times k factorial. So the k factorials are going to cancel. We're going to be left with k factorial, or k plus 1 in the numerator. This 3 times k plus 1 factorial, we're going to have to bring a lot of terms, a few terms out of the factorial for this to be able to cancel with 3k factorial. So we're going to bring out a 3k plus 3, 3k plus 2, 3k plus 1. So that way the 3k factorials can cancel. And then finally, we're going to rewrite the absolute value of x to the k plus 1 as the absolute value of x times the absolute value of x to the k. Absolute value of x to the k cancels, and we're just left with the absolute value of x. If you look closely, there's actually one more thing we can simplify, which is the 3k plus 3 term. If we take out factor out a 3 from the 3k plus 3, we're left with k plus 1. K plus 1 cancels with the k plus 1 in the numerator, so we're left with 1 over 3 times 3k plus 2 times 3k plus 1, all times the absolute value of x. So because we're doing the ratio test, we're going to take the limit of the ratio as n approaches infinity. In this case, it's going to be k. So we get 1 over 3 times 3k plus 2 times 3k plus 1. That limit is going to approach 0 because all the k terms are in the denominator here. We're going to have a quadratic term in the denominator here. So as k approaches infinity, this ratio is going to approach 0. So since this ratio tends to 0 no matter what x is, so we can take a look at that here. So we're going to be, since we're taking the limit as k approaches infinity, it has nothing to do with x. It only has to do with this sort of coefficient. So by the ratio test, k factorial over 3k factorial times the absolute value of x to the k converges for all x, and therefore the series k factorial over 3k factorial times x to the k converges absolutely at all x. So the radius of convergence is infinity, and the interval of convergence is negative infinity to positive infinity.